Let's make it helix. Oh, let's go like this. This is famous. Helix. So Vy is 5, Vy is 0.2, Vx is 1. So let's see what happens. It should be making a helix. That's not too noticeable. It's like this one right here. You see, so when you have a certain velocity that the charge has, the parallel component of the velocity is not affected by the magnetic field, only the perpendicular is. So then what happens is the parallel component of the charge will cause it to just go straight, and the perpendicular component is going to make it go in a circle, and it's going to cause it to helix like this, go in a helical path. See, like a corkscrew like this. And you might have seen pictures like this of the solar wind interacting with the Earth's magnetic field. The magnetic field, then they release the aurora, a lot of energy, the aurora borealis. You see, so they make a helical path. Variable solar wind can give some radiation belt particles enough energy to spiral into atmosphere and create aurora. You see, so then how does that case happen? The simulation should have been able to do it. But we didn't really see it happening. So if this is the X direction, let me tilt it so that the Y is like this, and then the Z is toward you. So I'm tilting it kind of like that. So then the Vx would be this way. Vy is a little smaller, right? So Vx is 1, and then By is this way. So this component of the V will not be affected by the B, you see, because it's moving in that direction. So that component is not affected. Only this component is affected, and the circle that it makes has a radius of, so that means you only use this component of the V to calculate the radius of your circle. This component does not feel the effect of the magnetic field. So it's just M over Q, which is just 1. And then V is going to be the Vx over the B. And then Vx is going to be, what was it? 1. And then the B was 5 Teslas. So the radius should have been 0.2 meters. Right? That's what I was expecting, kind of small circle. But then what should have been happening? The Vy should cause the charge to go this direction. Okay, so then what should the path look like? Vx crossed into B out of the board, right? Vx crossed into B out of the board. So the charge should come out of the board and go like that, and like that, like that, like that. So it should look like this. Out of the board, into the board. Out of the board, into the board. Out of the board, into the board. So that's what should be happening in that simulation. The radius of that circle from here to here should be 0.2 meters. And then the distance between these should be what? That's called the pitch, what was it called? The pitch of the helix, I believe. The pitch, let me see how it's spelled. Pitch of helix. Yeah, it's the pitch of the helix, the distance between each helical chord. So then, what should that be? Well, we can calculate the time that it should take for one circle, right? So the time is going to be 2 pi r over v, right? And then the r is 0.2. And then the v is not the vy, but the vx. In other words, it's the velocity that is involved in the circle. It's this one like this, you see? So it would be the vx. So which would be in this case 1. So this would have been the period of the circle. 2 times pi times 0.2, 1.257 seconds. So during that time that it goes in a circle, how far does it travel this way? You see, that's how to calculate the pitch. P-I-T-C-H. The pitch is the V parallel times the period. In other words, the parallel component of the velocity with the magnetic field. So this is the parallel component because it's in the same direction as the B field. And then we can call this the perpendicular component. You see? So then to calculate the period, you're doing the perpendicular component. And then to calculate the pitch, then you're doing V parallel times T. So 0.2 times 1.257. 0.25 meters. Okay, so that means this should have been 1/4 of a meter and the radius should have been 0.2 meters. Well, that's a big pitch. It's even bigger than the radius. Wow, I'm surprising that simulation wasn't able to produce that 0.25 and 0.2. That means this should have been let's refresh it. Helix. So it should have been like this. It should have just literally been like this. And then 0.2 meters is something you should have noticed. It should have gone like this. You see? Let's run it. Come on. No, I don't see it at all. It just keeps repeating it. There's some glitch, I think, somewhere.